Hey guys, welcome to Unit 5, where we are going to start comparing linear functions to understand their relationships here in this first target. So we've talked a lot about linear equations and functions. We learned about what the solutions were to a linear equation back in Unit 3, Target 4. We then graphed those solutions in Unit 4, Target 3, and learned how to write equations and functions in using our forms of our linear equations in Target 2 in Unit 4. So far, everything we've dealt with when it comes to our linear equations or functions, though, has been dealing with an individual linear equation or function. In this unit, we're going to start dealing with multiple linear equations or functions at the same time. In the simplest terms, if we were to take the solutions of two different linear equations and put them on the same coordinate plane, they could either intersect or be non-intersecting. Pretty straightforward there. All right. There are three different types of relationships that we can get from those two different categories. The first one is a single intersection. We see here these two roads kind of shows a single intersection. There's one point at which they intersect each other. Coinciding. Coinciding means that we literally have one line laying on top of the other. They share every single point is exactly the same. You can see this in this picture here. These two roads, 17 north and 60 west, are literally the same exact stretch of road there, even though they are two different roads. All right, and then the last relationship we have is parallel lines. You can see that's like two roads that run next to each other that never intersect. They're going to never have a point where they intersect each other. So let's now start talking about this when it actually comes to our lines. So what I want you to do is pause the video for a second when I tell you to, and find the slope of each of these lines. Ready? Pause. All right, let's see what you got here. Did you get the black line was 10/3 and the red line was 5/6? Now, if you notice, these lines intersect once, and where focus is on the slope, because as long as the slopes of two linear equations or linear functions are different, not the same, they will have a single intersection. All right, so now I want you to do the same thing with the green and the yellow line here. Find the slope of each of those lines and find the y-intercept of each of those lines. Ready? Pause. All right, let's check here. So hopefully you got that -1/3 is the slope for both of them, and 0,3 is the y-intercept for both of them. So what this tells us here is that our slopes and the y-intercepts are exactly the same. We're going to have equations where our slopes and our y-intercepts essentially are the same, and if it's in slope-intercept form, that's obvious. But when we have equations in point-slope form, or if they're not given to us in a form, it's not going to be as obvious whether they are coinciding or not. But really what we have here is two lines that literally have the same exact points, the same exact ordered pairs, all the way from infinity to -infinity there. All right, now our only category we're going to talk about here with our non-intersecting lines are called parallel lines. So once again, slope, y-intercept. Ready? Pause. Okay, let's see what you got here. So you can see both have the same slope as they did with coinciding lines, but you can see that the y-intercepts are going to be different here for these two lines. This is what makes these lines parallel. They have the same exact slope, but the place where they're going to cross the y-axis, the y-intercept, is going to be different. These will never have a point of intersection. There will never be a time where they share an ordered pair on their lines. So let's kind of refresh everything that we just did and put it into one nice, concise graphic organizer here. So our deal for special relationships of our lines here, there's a single intersection if the slopes are different. Right? There is coinciding if the slopes and the y-intercepts are the same. And they're parallel if the slopes are the same but the y-intercepts are different. Now, I will say, obviously, the easiest form to work with these lines in is going to be slope-intercept form. And we are going to be working with some examples here in just a second in slope-intercept form. But you might be given an equation that is not in slope-intercept form, which is why we learned how to rewrite the equations into slope-intercept form back in Unit 4. So let's take a look at each of these. So the first one, we can see that right off the bat, m is -3 in f of x, and the slope is 5 in g of x, so these are going to be a single intersection. In number 2, same deal. Slopes are different, single intersection. Now in number 3, our slopes are the same, so we've got to ask ourselves a question. Are we dealing with coinciding lines, or are we dealing with parallel lines? Well, since the y-intercepts are going to be different there because the b values are different, these are parallel. In number 4, you can see same slope, same y-intercept. These are going to be coinciding. All right? So here's a couple more examples. There's 8 of them. I want you to try these on your own. Pause the video and decide what the relationship is going to be. Is it going to be parallel, having a single intersection, or is it going to be coinciding? Ready? Pause. Alright, let's see how you did. So take a look at these. If you did not get the same relationship that we have here in the video, please make note of that, come to class, and let's ask some questions. Understanding these 3 different types of relationships and understanding what these relationships tell us about the intersections of these lines is going to be really important as we move into solving our systems of equations in Unit 5. Well, that brings us to the end. Hopefully this was informative, and you make sure this stuff gets locked down in that long-term memory. We'll see you in class.